Welcome, ladies and gentlemen. I wanted to show you some more of the PCBs I built and designed in the last year. As I showed you recently one of the use cases for the button board PCB, I wanted to show you today the pxlBlck multi-PCB, because this is actually one of the PCBs I started in at the beginning of 2021. That actually looks like this. On one side you have all the components. On the other side you have a 10 by 10 RGB LED matrix. But before I show you what all these components are about, I want to tell you why I thought it's time to design a PCB like this. As some of you know, I'm really into these tiny LED matrices. These, probably most of you know them from AliExpress or Amazon. They are pretty cheap, I guess they're about 8 euros, I don't know. And you can really easily interface them with any microcontroller that works in the range from 0 to 5 volt logic levels. I use them together with one of these custom PCBs that I solder to the LED matrix. And on the other side I have one of these Wemos D1 Mini breakout boards for the ESP8266. I think that's also a microcontroller I don't need to tell you much about, because it's widely known. That's one of the first really cheap IoT capable microcontrollers that are about, I don't know, if you buy this one, it's probably about €1. So the idea I had for my smart home was that I simply put my sketch on the ESP8266. I connect it to my Wi-Fi, to my MQTT server, and then I can send data to it, of course, that triggers animations, icons, whatever. So for example, if my doorbell rings, I can show a bell. If somebody writes me on WhatsApp, I can show a WhatsApp icon, so that I have like a optical notification about what's going on in my smart home. The thing about this one is here, when you use the Wemos D1 Mini this way, like it's here connected, I have one huge limitation. And this is the micro USB port you see over here. Because these micro USB ports are limited to 500 milliamps current dissipation. So you should avoid to power these LED matrices with full power, because each of these LED can draw up to 60 milliamps. Multiplied by 64, you can imagine that this is a lot more current than these 500 milliamps. So probably by a software issue or whatever other possible error, you could break this whole PCB or the micro USB connector. And that was one of the main reasons why I thought, okay, it's time to fix this problem. Not only in software, because earlier I solved this in software, so that way that I limited the maximum brightness of the LED matrix. But everybody knows, everybody makes mistakes, so I wanted to be on the safe side and develop a PCB where I don't have to care so much about this probability issue. Yeah, that was the first reason why I thought it's time to switch to a USBC connector. That's the one you can see already on here on the multi-PCB. Because this is capable to draw up to 3 amps or even 5 amps, depending on what supply standard you are using. Because some of you maybe know that you can also use power delivery with these USB-C connectors. Yeah, but that's another story, because I don't use it here. I use it only for the standard USB-C charging, and this is capable to deliver up to 3 amps at 5 volts. So you can draw up to 15 watt over or via this USB-C connector. Yes, that was the first reason why I did this, or why I designed this. And then I thought, okay, when you're already working on a custom PCB, you can also see what's possible to put on there beside this USB-C connector. And that's probably also the reason why this PCB is called multi-PCB, because as you maybe recognize, the multi comes from multiple use case. The first case is obviously the 10 by 10 LED matrix at the front. So I can already use this one and put it in a, okay, this is the 8x8 LED matrix housing, but I SLA printed one of these. That's a prototype. I don't know if it fits correctly, where you could put in this. Yeah, it doesn't fit, but I think you see where this goes. Same pattern like here. You put it on, you have an acrylic sheet at the front and it glows through it, and you have a nice 10 by 10 LED mattress to display whatever stuff you like. That was the first use case. The second use case was to print, to power other LED mattresses. For example, most of you know these LED mattresses. You can also get them from AliExpress, Amazon, eBay, whatever. They're also pretty cheap, about 12 euros, I think. And here you have an even crazier problem about current consumption, because you not only have 64 LEDs here, you have, what is it, 256 LEDs. Each one of this can draw up to 60 milliamps, so a lot of current can go to this. Also here I wanted to be on a more safe side. Of course, USBC is not completely capable of the occurring currents or possible occurring currents, but it's better than powering it by micro USB. So you can use the multi-PCB to connect to these LED matrices as well. Therefore here's a first prototype. Connected the multi-PCB with one of these solder pads you see over here. Wait, I will show you. So I designed the PCB this way that you have 5 volt solder pads, here three in a row, and 3 G&D solder pads where you can connect multiple wires to supply the LED mattress. Because as you can see here, you have 3 points where you can supply the LED mattress with power, and of course at the beginning and at the end 1 additional solder pin for the LED data. That's also here, that's the data out pin from the ESP32 I have in here. And this way you can, for example, also power and supply the LED matrices like this with data. But not only this. Additionally, I worked on another housing for these wider LED matrices. That is an 8 by 32 pixel LED matrix that you can easily interface the same way like all the other LED matrices, but of course again you have to care about power and current consumption. So I had again a pxlBlck multi-PCB, connected it via the solder pads to the corresponding pads on the matrix, and this way you can easily also power and control this. You have one PCB that works for multiple projects, and also some other features that I will show you now. Here you can already see that I have a speaker connected to the PCB, because on the pxlBlck multi-PCB is not only the hardware to drive the LED mattress, there's also one of these MAX 98357 3-watt DACs. So that's an I2S DAC. That means you can supply these DAC with digital audio data from the ESP32. It amplifies it and can output it here on the connector with up to 3 watts of power. And therefore it's also possible to, for example, stream a wireless stream, a web radio stream, or whatever stream via this DAC through a speaker. And you can, for example, also play web radio or another signals, maybe notifications, whatever you like. Basically, there's not much limitation, but of course you are limited in power, so only 3 watt is possible. Another way to supply these DAC with data is via this micro SD card port. So here you can put in a SD card, micro SD card. And if you have MP3 files on it, you can play them via the ESP32 and output them on the connected speaker. And that's also the idea I had here. So I connected the speaker, this one, and you can play web radio, whatever you like. Of course, you need the correct sketch for it on the ESP32. That's basically one of the additional use cases for the pxlBlck multi-PCB. But there is a bit more. Beside this audio DAC, we also have TSL2591 That's a brightness sensor, so you can detect the brightness that is in the room, for example, to regulate the brightness of the LED mattress, so that in a dark room you have a darker LED mattress and in a brighter room you have a brighter LED mattress. We have a DS3232M RTC, that's a real-time clock. So you could, for example, display time on the LED mattress without the need to have a stable and working Wi-Fi connection to an NTP server or whatever. So this also works some kind of offline. Beside this, we have an ADXL345. This is a simple accelerometer. So it can measure the direction the PCB is orientated. That's pretty cool if you want to have a use case where you are turning the mattress around for anything, or I don't know, you have an alarm set and you want to disable the alarm so you can shake the device and it detects it. It's also connected via these interrupt lines to the ESP32. So for example, you could also say, okay, I want to save power. I put the ESP32 in sleep mode and it's powered up when I shake the device. Another IC here on the PCB is the MPR121. That's an IC that brings up to 12 capacitive electrodes. So you can connect capacitive electrodes to the solder pads here, up to 12. And this is a pretty cool way to bring some user input to this device, so without any physical buttons or whatever. So you can, for example, connect this to some copper shield, copper tape that is on the inside of the housing. And by touching the housing, you can trigger some actions. Or, yeah, basically that's the use case. But whatever you do with it, that's another story. Of course, depends again on the software you have on the USB32. This one is a CH340G. That's basically a USB to serial bridge. It's also commonly known. It's on many fake Arduinos. So when you connect a host computer or host device to the USBC, it simulates a serial device, and the ESP32 is connected via the serial lines to this device. So you are capable to flash the ESP32 from the computer or to read the serial data that the ESP32 sends back to the PC. Yeah, that's one thing. The next thing is this little transistor here. That's boring when you see it alone, but the transistor controls, it's not populated on the PCB, but I think it's up here, an infrared LED. So you can put on here an infrared LED, and this infrared LED is capable to send infrared signals, for example, to switch on or off your PC or whatever infrared device or whatever device that receives or reacts on infrared signals. So you have also a pretty easy way to integrate ER-capable device in your living room. So this is an easy way to also control infrared devices via your smart home or via the Wi-Fi connection, the MQTT server from your smart home. That gives you one more possibility to use it and an additional use case for the pxlBlck multi-PCB. This guy here is a standard quick connector. That's a standard by SparkFun, which basically is an extension port for I2C devices. So for example, if you have a simple I2C device, in this case it's a BME 208, you can connect it via this port here, push it in, and it's visible on the I2C bus for the ESP32. And that's a pretty cool way to connect additional sensors or actuators to the PCB that you're missing on here. Actually, in this case, you could also use the solder pad, because I have it here for the BME 280. I just don't populate it here because of the chip shortage right now. It's a pretty expensive component. So I told you about the microSD port already, because this is used mainly for the DAC, but of course you can also save any other data on it, maybe bigger animations you want to show on the LED mattress, whatever. The last component is this. This is an stemma connector. That's a standard introduced by Adafruit, which basically gives you 3 volt GND and a signal input or output, whatever. That's connected to the ESP32 as well. And there you can also connect additional hardware to extend the existing functionality of the pxlBlck multi-PCB. Yeah, one thing that I forgot is the battery mount. That's for the button cell. That's basically here as a backup battery for the RTC. Of course, you only need to populate this if you want to use the RTC feature. All the other things here, I have 2 buttons, but that's mainly for development reasons, to reset the ESP32 or to put it in programming mode. You don't really need to populate this, but in case you're tinkering around and you don't have the USBC or the CH340G connected, you can use these solder pads here to connect via serial to the ESP32. Yeah, that's it basically. Yeah, at the front I already told you about the 10x10 LED matrix. That's a pretty compact way to create an LED matrix connected to your IoT at work or smart home, and display information, even for the ones who are not capable to, I don't know, hear the doorbell, for example, or that's one of the use cases I have often in my smart home, is that I'm playing guitar, I have headphones on and you don't hear what's going on around you. But with some of these guys in your smart home, you will not miss what's happening. Yeah, I hope you liked the video. I will put some more information about these pxlBlck multi-PCB in the comment section. And if you like it, leave me a comment. See you next time.